Okay, so now the next part is code converters. Code converters के लिए पहले आप देखिए कि कोड कैसे कन्वर्ट होता है. And अगर आप ध्यान दें उस पे, just take one simple example of a code converter. Say for example you had a BCD code with bits B3, B2, B1, and आपने इसको convert करना है in respect to gray code G3. Okay. Zero, 1, 2, and 3, right? Because higher order यहाँ से होती है. So it's 3, 2, 1, and 0. ये इसका flat. Okay. Now if I have to convert this, we know how do. Can anyone you tell me that how do we convert into gray code? देखिए जरा आपने lecture से देखिए. Yeah. What? No, that is XS3 code. That is XS3. Right. So the first exactly XOR. So if I give you a question that implement a BCD to gray code converter, what you will do is you may draw a circuit that looks like something like this. That the first line itself goes. Now what about the next? It will be XOR of these two, B3 and B2, and it will generate what? G2. Okay? Likewise, I can use this B2 and I can get G1. Then I have B1. And I will use this B1 to generate B0 along with B0. ठीक है? ये a simple code converter. I am not going on many examples, but अगर मैं आपको बोलूँ यही चीज जरा अपने decoder से कीजिए. Can you do it? यही हाँ? बेटा देखो जो आपने बोला मैंने वही किया. पहली बिट ऐसे चली गई और दूसरी बिट G2 जनरेट करने के लिए इन दो बिट्स का XOR करना होता है. वही किया. ये तो आपने बताया. क्या है? सिंपल एडिशन. XOR तो सिंपल एडिशन ही है ना. XOR गेट से इसने एडिशन ही करा था. जी याद हाफ एड्रेस बनावन से इस तरह कैसे करा A plus B और XOR गेट ही यूज होता है ना. XOR गेट ऐड ही कर. आप सही बोल. वेरी राइट. गुड. यू आर ट्राइंग वेल. Okay. So now if I tell you to design this using a decoder or using a multiplexer, I hope that you can do that at this level because हमने multiplexer को use करना है कैसे वो भी देखा. ठीक है. एक mux say 2x1 mux और machine decoder circuit उसको भी हमने देखा. So next जो हमारे पास point जो रहता है that is अच्छा ब्याक चीज उनमें एनकोडर डिकोडर हम सब में पढ़नो. ठीक है. when we went on with encoder and decoder we said that they are more of like code converters like BCD to binary, octal to something, right? तो वो चीज हम वहां से why I am telling you this because ये एक heading है हमारे सिलेबस में code converters. you can relate it to already जो previous lectures हमने किए. ठीक. अगर उस पे क्वेश्चन आता है maybe we have that knowledge by this time. If you still have some questions, you can come to me, but we will take that cover. ठीक है? Is that okay? Now, next point, जो last point बचता है इस हमारे unit 2 में, and which will cover this is hazards. You write the heading, hazards in digital circuits. Hazards. 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 अभी हजार्ड होता क्या है, पहले लफ्ज से ही आपको समझ आता है दिस इज एन अनवांटेड इफेक्ट, राइट? हजार्ड्स इन डिजिटल सर्किट्स। अब देखिए जरा, okay, I'll just say here only. In digital circuits, due to propagation delay, unwanted change occur in the output. In digital circuits, due to propagation delay, unwanted change occur in the unwanted changes in digital circuits due to propagation delay. Unwanted changes occur in the output, which are known as hazards. What do I mean by this is, say for example, you have a simple AND gate and you give an input to the second terminal through a NOT gate. And let's say if this is A, let's name this as X, and this is your output Y. ठीक है जी? So ideally आप क्या expect करते हैं? Since this is a basic gate, आप expect करते हैं अगर आपने A पे logic 1 दिया, X पे उस टाइम क्या आएगा? Logic 0, and your Y should be eyes on board please. I said your A is input, आपने दूसरे input को एक inverter के through दिया. So when your A is 1, X is 0, Y should be 0. So if I draw this in a diagrammatical, I mean what we call it, later on we will see, we'll call diagrams like this as timing diagrams, but फिलहाल एक simple diagram. Let's say किसी time t0 पे मेरा जो इनपुट A था उसने चेंज किया फ्रॉम 0 to 1. ओके, नाउ आइडियली क्या होना चाहिए, एट द सेम मोमेंट मेरा जो X है वो क्या होगा, पहले हाई जब तक A 0 होगा, और जब A 1 हो गया वो हो जाएगा लो. क्या यही सही है ना? So this is your X, ये A का ग्राफ है, ये X का ग्राफ है, सही है, एक्सपेक्टेड, राइट? एंड आउटपुट क्या आएगा, जब A 0 है, X 1 है, output will be 0 after this point because of A being 0, and after T0 your A is 1, X is 0, your output should stay at logic 0 level. So your Y is always 0. And this condition is called as static 0 condition. That is, this will stay 0 always, so it is kind of a static output, a fixed output which should be 0. इसका नाम क्या रखा हमने? Static 0. ठीक? क्या रखा नाम हमने? Now if there is a problem in this 0, an unwanted change, obviously 0 will change to 1, not something beyond that. 0 से नीचे तो कुछ है नहीं डिजिटल में. So 0 will obviously change to 1. So in such cases where you have a static 0 and there is some unwanted change, and the change obviously is that you have a logic 1 somewhere unnecessarily coming up, this type of hazard is called static 0 का hazard. लेकिन का हम इंग्लिश में नहीं लिखते हैं. Static 0 hazard is the name. Static 0 का hazard. आया समझ? क्यों? Why do I call it static 0 hazard? Because 0 तो static होना चाहिए, लेकिन unnecessary change होगा. So this is called static 0 का hazard, or static 0 hazard. ठीक? So whenever you are supposed to define this static 0 hazard, you can define by using this, that it is that value, or it is that unwanted change where your output changes to 1 while it is expected to be equal to 0. So I hope you can write that part.